10, we're asked which integration technique would be the most efficient for evaluating this following integral here. X over 1 plus x squared quantity squared dx. So, I mean, technically you do have a couple of different ways you can look at this, but there is clearly a most efficient way in this case. So remember that even though you've learned things like trig substitution, integration by parts, partial fractions, all of that stuff, if something is able to be done by just basic u substitution, that is always going to be the simplest and easiest. And that is the case for this integral. So remember, the easiest way to tell whether something can be used or can be done by just u substitution is that if there is any part of the function where its derivative also exists multiplied times dx in the function, then we're good. So what I'm getting at here is 1 plus x squared is what's in the parentheses here. The derivative of that is 2x. We have an x there. Since the two, remember, constants are inconsequential here because they could always go in front of the integral. So our derivative is in the function already. That tells you that u substitution would be the way to go here. And we want our u to be 1 plus x squared. So just to show you what that would look like here, if we did our u substitution steps, we'd have du equals 2x dx. So then if we substitute it in, the x dx is right here, so we'd have du over 2. So let's put a 1/2 in front of the integral. You would just have du. And on the bottom, this was u, so we'd get u squared. And you can see that's a simple power rule. Be very easy to do from there. So u substitution is definitely the most efficient way for doing that integral.